Here's a single particle. Simple question. Where is it? Quantum physics gives a strange answer. Before you look, it isn't anywhere in particular. Its wave function spreads it across every place it could be at once. But look, and it snaps to a single spot. That snap is called collapse. And in 100 years, no one has been able to say how or why it happens. It's the deepest mystery in physics. We've always assumed that wave is something real, out in the world. But what if it isn't? What if it's all in your head? That idea is called QBism. This is the second episode of the series. Last time we found something strange. In the quantum world, everything is relative to the observer. Today we go one step further. Here's the experiment that forces the issue. Fire particles one at a time at a barrier with two slits. Each is a single particle, yet on the screen they build a striped wave-like pattern, as if each went through both slits at once. That only feels impossible if you assume each particle took one definite path. That assumption is the weird part, not the pattern. Now watch which slit each one takes. The stripes vanish, same slits, same particles. All that changed was your choice to look. And here's the tell. Without the detector, you describe it with one wave function. With it, a different one. If that wave were a real object out in the world, why would it flip based on what you decide to check? So maybe it isn't out there at all. Then what is it? QBism gives a narrow but radical answer. It isn't trying to explain why nature does this. It answers one question. What is the wave function? Think of the odds on a pair of dice. 7 comes up far more than 2, but that spread of odds isn't printed on the dice. It's your expectation. QBism says the wave function is the same kind of thing. Not a wave out in the world, but your information, your bets on what you'll experience. That's why it flipped when you looked in the double slit. Not because a real thing changed, but because what you knew did. And measuring isn't a peek at a value already there. Your action brings a result into being, and then your wave function updates to match. That's all collapse ever was. Not a physical wave snapping, but you updating. There was never a wave out there to collapse. That's QBism's claim. But a claim only earns its keep if it survives the hardest cases, so let's put it on trial. The first test. 2 particles born from a single event are linked forever. Physicists call them entangled. Carry them light years apart. Measure one, and the other seems to answer in the very same instant. Einstein hated this. He called it spooky action at a distance. But that phrase smuggles in an assumption, that a real wave stretches between them, and touching one end yanks the other. Drop it. If the wave function is your information, then nothing traveled. You learned something here, so your expectation about there simply updated. No signal, no push. Does that explain why the 2 results always agree? No, QBism doesn't pretend to. It says no mechanism is needed. There was never one shared object out there to link. The spooky action dissolves, one assumption down. Now, the deepest test. Remember the deep problem. The equations never tell you when a superposition becomes a single outcome. Left alone, they just keep evolving the wave function smoothly, forever. So seal the lab so nothing escapes. Inside, your friend measures a particle, and to her, she sees one definite result. But you're outside. The honest thing is to do exactly what the math says. Keep describing the whole lab with the wave function because nothing has told you to collapse it. And nothing has. No result leaked out. So in your description, the entire lab, your friend included, stays a superposition of she saw heads and she saw tails. You're not peering in at some literal wave, you just have no license to call it settled. She says her result is real. Your honest math says nothing is decided yet. Same experiment, 2 irreconcilable stories. QBism's answer is radical. There's no observer-free fact about what happened in that lab. Her result is real for her, created when she lived it. Yours stays open until you break the seal. Not 2 opinions about one hidden truth, but 2 experiences with no fact above them to match. If this sounds like giving up, hold on. We've made this exact move once before, and it was a triumph. Probability. For centuries, people argued over what a probability really is. Was it something hidden in the dice? The answer that finally worked was stranger. It isn't out in the world at all, it's your own uncertainty. And that idea now runs statistics, economics, even artificial intelligence. QBism says quantum mechanics is just the next thing we've been misreading. Decades ago, John Wheeler felt it coming. He said no phenomenon is a phenomenon until it is an observed phenomenon. QBism is that hunch, made rigorous. So what does this cost us? If the wave function is your information, physics is no longer a God's eye view. There's no view from nowhere. Does that mean nothing is real except your own mind? Is this solipsism? No, because the world kicks back. It hands you experiences you never chose, results you cannot wish away. Reality is still there, it just doesn't come pre-labeled with values waiting to be read. QBism says the wave function was never a portrait of that world. It's a user's manual, a tool for placing your bets. And that is the honest price. A manual tells you how to act. It never tells you what the world is made of when no one is looking. So, does it work? Look back. The measurement problem. Spooky action. Wigner's friend. 3 famous paradoxes, and everyone was the same assumption, cracking. The assumption that the wave function is a real thing, out there. Drop it, and the weirdness has nowhere left to live. The wave function was never a picture of the world. It's a manual for your experience. Is that the deepest honesty in physics, or a clever way to change the subject? You decide. But the next paradox comes for something you hold even tighter. Were you ever truly free to choose? That's super determinism. Next time. Subscribe at Quantum Red Hot.